Okay, welcome to today's video on SUVAT Equations. This is another video on motion physics, and today we're going to define what these equations are and use an example to solve. So what are these SUVAT equations? So they are the 5 equations of motion that are related to constant acceleration. Which could be speeding up, slowing down, or going at a constant velocity. Now these relate to generally 1D motion, but could relate to projectile motion where you actually split it into horizontal and vertical components. So the SUVAT equation comes here. So S represents displacement, U represents initial velocity, so start velocity, V is the final velocity, so the velocity we end with, A is acceleration, and T is the time. Okay, so all these equations involve 4 out of 5 of those values. So the first one here is V equals U plus AT. The second equation is S equals UT plus half AT squared. The third equation here is S equals half bracket U plus V times T. The fourth equation is V squared equals U squared plus 2AS. And the fifth equation here is S equals VT minus half AT squared. Now, each of these 5 equations have 4 of those variables in it, and there's one missing. So the first one here, for example, has no S or no displacement. The second equation has no final velocity V. The third equation has no acceleration. The fourth equation has no time variable T. And the fifth equation has no initial velocity. Okay, so we can pick and choose which formula applies depending on what we're given in a question. Okay, so how do we solve questions with SUVAT equations? The first step here, what we actually do is we highlight the key information in the question. So usually underline the bits of information that you need. Second step is to write the knowns and the unknowns out. So we generally write A equals something, B equals something. Also write down U or whatever we don't know as a question mark as well. Thirdly, we find the appropriate SUVAT formula. Usually we know 3 out of 4. And the fourth is the unknown, so we can pick the correct equation. And finally, we do the maths. So use an equation and substitute the values. Okay. Now, some tips. So the words stationary or at rest mean some form of velocity is equal to 0. So it could be final or initial. Constant velocity, that actually means our acceleration is 0, so there's no acceleration there. We also use the initial position, and we usually set that to be 0. So even if it's high up, we set that to be 0. If we speed up or slow down, when we speed up, generally we mean the acceleration is positive, and slow down, the acceleration is negative. And also define what the positive or negative direction is. And this is usually defined by our velocity, or where the direction of velocity is at the start. So U, the initial velocity. Okay, now let's go through an example question. This is a kangaroo escaping the bushfire, so it's quite an appropriate one given the horrible fires we've had here in 2020. A kangaroo runs away from a bushfire at 16 meters per second and slows down at a rate of 2 meters per second squared. This occurs over a time period of 5 seconds. And what is the distance the kangaroo travels? So underlining the key bits of information: 16 meters per second, slows down at 2 meters per second squared, period or time of 5 seconds, and what is the distance or the displacement the kangaroo travels. So that there, we've highlighted our key information that relates to the SUVAT equations. The second step is, as we went through before, is define the unknowns and knowns and unknowns. It's really important that we actually put these down. Okay, we write them on the paper. So we've got u, our initial velocity is 16 meters per second. The acceleration is minus 2 meters per second squared. That's opposite to the motion. So remember, we're defining u as being positive, and so the acceleration is going opposite because it's slowing down. So it's minus 2 meters per second. Thirdly, we've got the time, or the time period, 5 seconds, and we don't know the distance, or the displacement is what we're trying to find out. So given that we know know 3 of those 4 things, but it involves all those u, a, t, and s, we find the right SUVAT equation, which doesn't include v. So we can find that there. The equation that we'll need is just this one here, so s equals ut plus half at squared. Okay, so that's the one there that has no final velocity component. Now, turns out this is fairly straightforward. We go to our final bit of this question where we just do the maths. So we use that equation, substitute those values in, and solve. Now, this is an easy one because s is the subject. We're going to write the equation there again and solving for s. In other instances, we should just find the value, insert the values, and we might have to find u or a or t. So here we go. S equals 16 times 5 plus half times minus 2, remember there, times 5 squared. Okay, so inserting those values of u, a, and t to find s. Now 16 times 5 is 80. And we're taking off half of minus 2, which is minus 1, times 25, so taking off 25 there. So that gives us 80 minus 25, which will give us an answer of 55 meters. So the kangaroo in that 5 seconds is going at a rate of knots, is going at 55 meters. So there's our answer there. We should actually check the distance in case later, in case it actually goes backwards. And in that case, the distance is actually different to its displacement. Okay. Thanks for watching today. Make sure you subscribe. It's really appreciated as always. And definitely ask any questions you've got further in the comments below. Thank you. Bye.